Hi, welcome to WOW TV. My name is Angel, and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today, you're going to learn something about rocketry and experiment with testing thrust. Let's get started. Can an airplane fly into space? No. But do you know why? Well, airplanes need air to fly, and there is no air in space. Airplanes have propellers, angled blades that push air like a fan does. Airplanes also have wings that use air to help them stay in flight. With no air in space, rockets can't use propellers or wings, which is why they don't have them. So, how do engineers get rockets into space? Rockets that are launched into space are very heavy and require something powerful to push them. Engineers design rocket engines to do just that. The push that a rocket engine provides is called thrust. There are 3 laws of motion, Newton's laws of motion, and his third law says that for every action there's an equal and opposite reaction. Think of those actions as forces. For every force, there is an equal and opposing force. That means that as the rocket engine pushes hot gases out of the rocket propels or pushes forward into space. That forward push is called thrust. So, is getting a rocket into space just as simple as the third law sounds? No. Rockets are big and heavy, and it takes a huge force to launch rockets into space. Engineers must consider 3 main things when designing rockets that can be launched into space: thrust, weight, and control. Thrust directly relates to Newton's third law, which tells us how rockets move, by pushing out mass in one direction to move in the opposite direction. In some rockets, the thrust comes from pushing out hot gases that come from burning fuel. When the engines fire, it boosts the rocket upward against the Earth's gravity, and at the same time, the explosion of fuel generates a force within the bottom of the rocket. How do you think weight affects a rocket? Well, the heavier the rocket weighs, the more thrust it needs to take off. Lastly, engineers have to work on rocket control to get a rocket to move in the right direction. Control is important for getting the rocket past the Earth's atmosphere safely. Engineers must specifically design rockets to be balanced and stable while flying. In order to create a successful rocket, an engineering team must understand thrust and know how much force it is creating. What do you think could affect the thrust of a rocket? Perhaps a bigger engine? Yeah, but that would change the weight too. There's something else that engineers can do to affect thrust as well. How an engineer designs the shape of the rocket nozzle is very important to the performance and thrust of the rocket. A nozzle is a device designed to control the direction of a fluid flow. Think of the nozzle that we can add to the end of our garden hoses. It can control the speed, the force, the pressure, and the direction of the water. The size and shape of the nozzle affects how fast the exhaust will leave the rocket, as well as how much pressure it will have. You must design a nozzle that will create enough thrust to launch the rocket into space. Today, we're going to design 2 paper rockets with different nozzle shapes. We will show how the different size nozzles affect thrust. After building your rockets, you will use your mouth as the rocket engine. By blowing air out of your mouth, you can launch your paper rockets into the air. Do you see what I have on the end of my rockets? Why do you think the cotton ball has been added? Engineers have to take safety into consideration when designing rockets. We will add a soft cotton ball to the front of the rocket to protect its landing. Now, let's talk about what is going to happen in our activity. You will investigate the effect that thrust has on rocket flight. You will make 2 paper rockets that you will launch by blowing through a drinking straw. Your rockets will differ in diameter. Then you'll compare the distances that your rockets travel. Your teachers have the directions for you and the data sheets you'll need so you can record your results. Before you begin to do that, let's talk about your 2 rockets. When making your first rocket, you'll roll a half a sheet of paper around a pencil into a cone shape. Check the final length of your rocket to make sure it's at least a few centimeters shorter than your straws. If you need to, cut the rocket so it's shorter. Then pinch and fold the smaller end of the tube and tape it so it's airtight. That's the nose of your rocket. Then tape some cotton to the nose of your rocket. To make your second rocket, when wrapping the paper around your pencil, avoid the cone shape this time. It should be more even in diameter along the entire length. You'll finish it just like you finished the first one. When you have both finished, you should see that your first rocket has a large opening and has not been rolled up very tightly compared to the smaller opening on your second rocket, which was rolled much tighter. The loose spiral, rocket number 1, has a large nozzle, and rocket number 2 has a smaller nozzle. As you're testing them, you'll see that one of them will have more thrust than the other. Teachers will pause here as they make their rockets and as you give them their data sheets. As they do that, you can prep your room for their tests. Make a starting line on the floor with tape or string. In the binder I sent you, you'll have pictures of planets to lay on the floor and the distance to lay them out from Earth. I'll meet you back here to go over directions for their rockets' launches. Okay, you must be ready to launch those rockets. To launch your rocket, insert your straws into the rocket, holding onto the straw, not the paper part, aim at a planet, and blow. When you're given time, you should probably practice a few times to get the hang of it. After your teacher assigns you to a group of 3 to 5, here are the steps to follow. Choose a planet to aim for. Taking turns, launch your first rocket from Earth. After retrieving your rocket, answer the 3 questions on your data sheet. After everyone in your group has had their first attempt with their first rocket, each of you can have a second attempt with that first rocket. Then repeat all of it with your second rocket. Please remember that rockets should not be launched at each other. Okay, teachers, I'm turning this over to you. Thanks for joining me today, and thanks so much for using this WOW lesson. Please check out more at our website at wpafbstem.com.